Welcome everyone. My name is Amparo Lopez and I'm professor in Hydraulic and Environmental Department in Technology University of Valencia. Today we will be speaking about how does a particular fluid affect the behavior of a hydraulic turbo pump. When we finish, we will be able to know how to understand the influence of the nature of the pump pumped by a hydraulic turbo pump in a particular system. First, we will be speaking about fluid properties and the interactions within the pump behavior, head versus pressure, selecting these pumps, cavitation, pump priming, and some conclusions. These are the aspects in which the fluid involves the behavior of the pump. So, which are the main fluid properties which affect a pump? First, we have the density. The density is the mass containing unit of volume. This property affects the energy involved in the movement of the fluid. If we move a fluid more dense with heavier conditions, we will have to use more force and then more energy and then more power. So it's important, the density of the fluid. And then we have the viscosity. It's the flow resistance to flow caused by shearing stresses. In this case, viscosity will affect the losses inside the pump and the movement of the fluid within the morphology of the pump. So we will have to choose also a particular pump for a particular fluid and know how it changes with viscosity. Then we have in this case, the vapor pressure, which affects cavitation because it will make that some bubbles of vapor appears in the movement of fluids and then it will affect to the flowing pulp by the pump. So let's speak about head versus pressure. Head is a measure of energy in an energy balance in Bernoulli equations, whilst pressure is the force applied against a particular fluid. Normally, we express the curves of the pump in terms of head, as we see here, but depending on the flow, this pressure can change. So when we have curves like this, we express it in flow versus head, and with different pressures, we will have with different fluids some different behavior in terms of energy in each pump. When we select a pump, we must use the best efficient point. In this case, consider the method of column of fluid, considering, as we say, the density of the fluid to be chosen. When we select a pump, also we will have to consider the viscosity. Here we introduce some sort of affinity laws introducing for selecting pump with viscosity, which we will not develop today, but we must say when we select this pump, we must consider this viscosity to choose how is the behavior of the pump. And as we indicate, also cavitation is very important for the selection of a pump and for the behavior of the pump. When pressure gets very low, cavities of vapor can appear and they can move inside the impeller. When this happens, the pump has very critical behavior. It does not behave very well near the cavitation point. To do so, we must know two curves, the NPSH A and the NPSH R. NPSH R depends on the pump. So we must choose a pump with a particular flow to be able to have also always this situation with a margin in which NPSH A is bigger than NPSH R, and it is very important depending on the flow. As in this case, NPSH A has the pressure and in this case the vapor the pressure at the end of the expression, and it is very important to consider this. Also, we have the pump priming. This is the process of removing air from the pump and suction line, and it is important to be done always when we begin the activities of a pump. In this case, we will need to know which is the density of air in terms of the density of water. The property density affects very much the pump priming, because if we have air which has a different density, the pump doesn't behave as it should. So we must ensure always that we have, in this case, like here, some head of water in order to avoid the possibility of air in the part of the beginning of the movement of the flow. So, as we have indicated, these properties of the flow affect very much to the selection of a pump, affect to the energy required in terms of pressure, about viscosity and density, affect the operation point in terms of pressure in viscosity and density, affect the cavitation point, and affect the selection at the end of the machine. So if we buy a pump to work with water, we must consider very well what will be happening with other fluids, let's say benzene, let's say oil, in order to know how will be this behavior with different fluids, which sure will affect to the operation point, the cavitation point, and the energy implications of the pump. I hope this has been of your interest. Thank you very much indeed.